All right, today we're going to spend a second day on lesson 4.7, which is absolute value functions. And essentially, we're graphing these. Today, we're going to look at a couple of the characteristics of these graphs that will help us understand where it's going to be and what it should look like prior to even making the graph, and as well as doing some more of the more complicated ones, I guess. Okay. So first of all, let's look at one that involves a little bit more than what we dealt with yesterday. So this equation, there's just more to it. I mean, we're going to take 2 and multiply it by the absolute value of x minus 3, and then add 1 to that result. So this is going to take a little bit more math. We want to get used to making these tables and carrying out a table that's going to justify our answer. Okay. So I'm going to start this time with -1. All right, so I'm going to substitute -1 in here. -1 minus 3, that's -4. Absolute value of -4 is 4, times 2 is 8, plus 1 is 9. So the order pair -1, 9 is on my graph. 0. So 0 minus 3 is -3. Absolute value of -3 is 3, times 2 is 6, plus 1 is 7. So 0, 7 is on the graph. Put in 1. 1 minus 3 is -2. Absolute value of -2 is 2. Times 2 is 4, plus 1 is 5. So 1, 5. Put in 2. 2 minus 3 is -1. Absolute value of -1 is 1. Times 2 is 2, plus 1 is 3. So 2 3's on my graph. Put in 3. Okay, 3 minus 3 is 0. Absolute value of 0 is 0. Times 2 is 0, plus 1 is 1. So 3, 1. Now notice my values, 9, 7, 5, 3, 1. They're going down by 2's, but they're going down. So I still haven't gotten to the bottom of this graph and started headed back up yet. So hopefully we do that soon. Put in 4. 4 minus 3 is 1. Absolute value of 1 is 1. Times 2 is 2, plus 1 is 3. So there you see, we went down to 1 and now we're heading back up again. So 4, 3. And then I put in 5. 5 minus 3 is 2. Times 2 is 4, plus 1 is 5. So 5, 5. Okay. And then we make the graph. So we plot our order pairs. -1, 9 is way up here. 0, 7. Okay. 0, 7. 1, 5, 2, 3, 3, 1, 4, 3, 5, 5, and there it is. There's our graph. Now you may say, well, how did you know to start at -1? Well, we'll talk about a little bit about more of that in a second. But even if I would have started at -3 and got to 3, I would have just started to notice our change in direction again. Actually, no, I wouldn't have. I would have had to get to 4 to see it. So if you don't see a change in direction, if I'd have started at -3, I would have just had a part of the graph that comes down like this. I know it's V-shaped, so we got to keep moving to the right to find out where that bottom is and then how we're heading back up again. Okay, let's do another one like this. We're going to graph absolute value of 2x minus 3 plus 1. If you notice, the last graph had the 2 on the outside times the absolute value. Now I moved it in here and see what that does. Okay, I'm still going to make a table of values. So I'm going to put in -1. Okay, 2 times -1 is -2. -2 minus 3 is -5. Absolute value of -5 is 5, plus 1 is 6. So -1, 6. Put in 0. 2 times 0 is 0. Minus 3 is -3. Absolute value of -3 is 3, plus 1 is 4. So 0, 4. You got to be able to do this math, guys. Okay, 2 times 1 is 2. Minus 3 is -1. Absolute value of -1 is +1. Plus 1, 2. So 1, 2. Okay, put in 2. 2 times 2 is 4. Minus 3 is 1. Absolute value of 1 is 1. Plus 1, 2. So you can see, we were at 6. We're down to 2. Now we're back up at 2. So we should be headed up. These values should start increasing again. 2 times 3 is 6. 6 minus 3 is 3. Absolute value of 3 is 3. Plus 1 is 4. Put in 4 for x. 8 minus 3 is 5. Absolute value of 5 is 5. Plus 1 is 6. And then put in our 5 here. 10 minus 3 is 7. Absolute value of 7 is 7. Plus 1 is 8. Okay, so if I go over here and graph this, plot these ordered pairs, my graph's going to look like this. Now, what you might notice here is that our vertex, the very bottom of our graph, is actually right here, and that's at, looks like 1.5. All right, I didn't put 1.5 in here, but it looks like that's where the vertex is. So I kind of had to estimate where the bottom is, and then head back up again. There's symmetry here, so we can make that adjustment. Okay, all right. Now, let's analyze all of the things that can occur to our absolute value function and how it affects it. Okay, so there's three different things that can happen. I can multiply the absolute value by a number, which we call A. We can add or subtract a number inside the absolute value from X. That's what we call the H. And then we can add a number or subtract a number outside of that, which is what we call the K. All right. Each one of these has a characteristic that it applies to the graph. So let's talk about the K first, the number out here. So this is the number added outside of the absolute value. So it's going to affect the Y values. Okay. If K is greater than 0, then the graph is translated up K units. So what that means is we move it up the Y axis K units. If it's less than 0, we're going to move it down the Y axis K units. So if this was +2, okay, then I would go from from 0, 0, the origin, I'd go up the Y axis 2, and that's where my graph would start. Or if it was -2, I'd go down 2 from 0, 0, and that's where my graph would be. Okay. The H, which is inside here, it's going to affect our X value. So it's going to move us left and right. So K moved us up and down. X is going to move us left and right. Okay. So what we got to look at here is whatever the sign is, we do the opposite. So if it's -H, we're going to go to the right H units. If it's +H, we're going to go to the left H units. Okay. And that's easiest to see when I show it to you live here. So the H is going to move us left and right. K is going to move us up and down. That's our vertex I'm talking about. And then the A, we talked about this. They call it a compression or a dilation or a stretch. All right. If A is bigger than 1, if I'm multiplying by a number bigger than 1, then this thing's going to get skinnier, like we talked about in class, like compressed along the x-axis. If the absolute value of A is greater than 1, then it's going to get more narrow. And if the absolute value of A, oh, excuse me, this first part, I said this wrong. I'm sorry. If A is, this should say if A is less than 0. So in other words, if A is negative, we're going to reflect it over the x-axis. Okay. If A is a number bigger than 1, it's going to get narrower. If A is a number between 0 and 1, it's going to get wider. Okay, we're not going to do a lot of this right now. We're going to look a lot at this H and K business up here. Okay, let me show you what the kind of problem is. Okay, so what this says is the graph of Y equals the absolute value of X. That's our parent function, is shown below, right? This is our parent function, right? Let's translate this parent function of the graph absolute value of X plus 3. So the +3 is the K. Remember I said the K is the number added outside. If the number added outside is going to move our graph up and down. So since it's +3, every one of the points along this graph are going to get moved up 3 units. So the graph of the absolute value of X plus 3 is going to look like this. Every point gets moved up 3 units. It's like picking the vertex up and sliding it up here 3 units. Okay, that's just a shortcut variation there. Let's look over here. So we got, again, the graph of Y equals the absolute value of X is shown. Let's translate this one. Y is equal to the absolute value of X minus 3. Now this is inside the absolute value. So this is that H I was telling you about. All right, we're going to do the opposite of whatever this says. So this says -3. So I'm going to move it to the right 3. So the number inside absolute value moves it left and right. The number outside moves it up and down. So -3 says move this to the right 3 units. So this is what our graph would look like. It's the same function. You know, it's over 1, up 1, over 1, up 1, over 1, up 1, just like it was here. But everything just slid to the right 3 units because of that right there. Now we can make a table of values and show you that this is the way it is, but I'll leave that up to you if you want to verify. Okay. Now let's put 2 together here. So here's our parent function. Now we're gonna make the graph of the absolute value of X plus 4 inside absolute value, and then +3. So the number inside, we do the opposite, and that moves us left and right. So this means we're going to go 4 units left, and then this one says we're going to go up 3. So every point on the parent graph is going to go to the left 4, up 3, and we should be right there. So everything gets moved to the left 4, up 3, just looking at the graph. And that's our graph. And you can plug in ordered pairs and verify. Okay. This last one, So I got plus one, or excuse me, inside the absolute values minus one. So that means we're going to move to the right one. Plus three says move up three. And now because it's the opposite, that means flip the graph down. So we're going to move the vertex to the right one, up three, and then we're going to flip it down. And that would be the graph of this. So we can learn a lot just by looking at how this is written, and we can estimate where these are going to be. But a table of values is still helpful. Okay. So when we're graphing these, you still need to make a table of values. All right. But for these, when they ask you to translate them, you can do it this way. Okay. So the homework tonight is going to be looking at those concepts. So, use the examples as I just showed you. There's more examples that you can look at through the ALEKS site. But, that's what we're going to work on tonight. And I will let you have at it.